All right, we're on module 7.2, finding complex solutions of polynomial equations. This is day 1. So multiplicity is a new vocabulary word. A factor that occurs more than once has a multiplicity of the number of times it occurs. Okay, so I want to kind of talk about what multiplicity means. If you look here, we have this polynomial, and I've already factored it to x plus 2 times x plus 3 quantity squared. What that really means is x plus 2 times x plus 3 times x plus 3. Now, if we use the zero product property to find the zeros, we would say x plus 2 equals 0, x plus 3 equals 0, and x plus 3 equals 0. This one solves to x equals negative 2, x equals negative 3, and x equals negative 3. Now, one of the things you'll notice is negative 3 showed up twice. This is called a multiplicity. So, multiplicity means negative 3 has a multiplicity of 2 because it shows up twice. And that's all that means, is that the answer's there more than once. Now, we're going to find all the zeros, including any multiplicities greater than 1. We're going to practice working on some problems. So we'll slide the board down. We'll look at a few examples. So we have p of x equals x cubed plus 7x squared. So we want to factor this. Remember, whenever we factor something, we always look to take out any common factors. And in this case, I'm going to take out an x squared. If I do that, I get an x plus 7. Now, an x squared means that that is x times x plus 7. That's what it factors to. And using the zero product property, I get x equals 0, x equals 0, and x plus 7 equals 0. So my answers are x is 0, x is 0, x equals negative 7. So in this case, 0 has a multiplicity of 2 because it shows up twice. Now, is it possible that something shows up more than twice? Yes. So next one is using the cubic. It is a difference of 2 cubes. So remember, that's factoring to a minus b times a squared plus ab plus b squared. We learned that little factoring pattern. And so we're going to look at this and identify, well, that means that a is x and b is the 4 value. So I get x minus 4 times x squared. 4 times x is 4x. And 4 squared is 16. Now, this has some zeros that are real and some that are not real. If I set each factor equal to 0, because I can't get numbers, I can't get any values that when I multiply to get 16, I can't get any of these to add up to 4. I can get 17, I can get 10, and I can get 8, but I can't get 4, which means I'm going to have to finish this one off with the quadratic formula. Here, I get x equals 4. Over here, quadratic formula says this is a, this is b, this is c. Opposite of b is negative 4 plus or minus the square root of b squared, which is 4 squared minus 4 times a times c divided by 2 times a. Cleaning this up, multiplying 4 times that negative 16 in the inside and squaring our 4. This gives me 16 minus 64 divided by 2. 16 minus 64 is giving me the negative 48. I'm going to move it over just slightly. Divided by 2. Negative 48, if you remember back, it is a non-real root. We can simplify this down. If I take negative 48, remember I separate the negative 1 times 48. Negative 1 is I. Remember imaginary numbers. And breaking down 48, that can be 16 times 3. And 16 breaks down to 4 times 3. So the pair comes out. So this ultimately simplifies down to 4i square roots of 3 over 2. And then you can take it one step further and divide everything by the 2. So we get negative 2 plus or minus 2i square roots of 3. These are what we consider the non-real solutions. And we have one real solution here. We don't have any multiplicities, nothing that showed up more than once. But we do have real answers and non-real answers. Anytime there's a negative inside the radical, you're going to have a non-real solution. All right, so we have another example over here, number 3, that we want to look at. See if we have any multiplicities. We want to factor it completely. This is a fourth power, which means we want to use the m over n. So looking at m, that is negative 8. We can get there by plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. N is simply 1, so it's a plus or minus 1. So when we look at our values to test, m divided by n, it's simply going to be our m values, because when we divide by negative or positive 1, I'm not changing anything. And let's see, let's try testing 1. I don't know. So we get 1, 5, 6, negative 4, negative 8. Drop your 1 down. 1's easy to always kind of start with because it's a very simple number. There's 1 atomed up. There's 6. That's 12. 1 times 12 is 12. There's 8. 1 times 8, 8. Plus negative 8 is 0. We got 1. Now, this means that 1 is an answer, but then I have x cubed plus 6x squared plus 12x plus 8. Still got to factor it. The good news is, look at your end. It's still 8. So that means my m over n, I can still use these values, and I can try doing 1 again. See if it works. So let's test 1 here. It's 1, 6, 12, 8. Drop the 1 down. So 1 times 1 is 1. That's 7. 1 times 7 is 7. That's 19. 1 times 19, that's 27. So 1 in this case did not work. So let's try a different value. Let's try negative 2. See, because our positive didn't work, let's go with a negative. There is negative 2, that's 4, that's negative 8, that's 4, that's negative 8, there's a 0. So now let's look at what this factors down to, x squared plus 4x plus 4. Now, these are both positive, it's a quadratic, I can factor this, because I've got 1 and 4, 2 and 2. I can add 2 and 2 and get this middle value of 4. So, we actually have the solutions. X equals 1. X equals negative 2. If I use zero product here, zero product property, I get x equals negative 2 and x equals negative 2. So negative 2 has a multiplicity of 3 because it shows up 3 times. All right, so I want to do and talk to you about the fundamental theorem of algebra. And I want to look at things in the sense that we're going to talk about a theorem, and I'm going to go back and show you. So right now, I kind of want you to focus over on this other board over here. Fundamental theorem of algebra says every polynomial function of degree n greater than 1 has at least one 0, where a 0 may be a complex number. So it could be complex, which means it can have radicals in it and everything else. The corollary to this, every polynomial function of degree n is greater than 1 has exactly n zeros, including multiplicities. So, ladies and gentlemen, what this is telling reminding us is that the power of the polynomial gives away how many answers there are going to be. So I want to use that and come back and look over here at our problems. So this has a power of 4. We had 1, 2, 3, 4 answers. Sliding our board back down. This is a power of 3, and we had 1, 2, 3 answers. Now those were all with real values. Here, though, we have a power of 3, and we still have 1, 2, and 3. Because this has a plus or minus in it, it counts for 2. So we still have 3 answers. So the power of a polynomial gives away how many answers there should be. So when you're finishing a problem and you're going, oh, wait, man, I only got 2 answers, but my power was 3. That means you're missing an answer somewhere. So you need to go back and find it. This concludes day 1, and we'll talk about day 2.